we are going to discuss geometrical isomerism in oxime. Generally, the compounds which having C double bond N, that compound also shows the geometrical isomerism. Now, why this compound shows geometrical isomerism? Because there is different arrangement of atoms or group around the C double bond N, and hence we are having two different isomer, geometrical isomers. Now, let us see. Next point, configuration of ketoxime by using Beckmann's transformation reaction. The name of reaction is the Beckmann's transformation, or that reaction is also known as the rearrangement reaction, Beckmann's rearrangement. Now let us see how the configuration of ketoxime is determined by using this particular reaction. We can determine the configuration of ketoxime, means whether it is syn or anti by using this particular reaction. Okay, let us see what is Beckmann's transformation. पहिल्यांदा आपण बघूया what is Beckmann's transformation. Okay, this is simple example. Phenyl methyl. This is phenyl methyl ketoxime. When this phenyl methyl ketoxime is treated with concentrated H2SO4. Now what happens here? In this reaction, phenyl group migrates from carbon to nitrogen. यामध्ये काय होतं म्हणजे इथला हा जो फिनिल ग्रुप आहे तो मायग्रेट होतो अँड इट गोज ऑन द नायट्रोजन. हियर दिस हायड्रोजन गोज ऑन द नायट्रोजन while this oxygen goes on the carbon, means a specific migration of group takes place within the molecule and we get different product. Okay, this is the final product and this particular compound is called N-phenylamide and this reaction is called Beckmann's transformation. What is the reaction? Here, ketoxime on a reaction with the acid catalyst. For example, H2SO4 or P2O5, PCl5, BF3, SOCl2. Now this ketoxime undergo rearrangement to form substituted amine. We get N-substituted amide and this reaction is called Beckmann's transformation or Beckmann's rearrangement reaction. Now let us see how this reaction is used to determine configuration, means whether that ketoxime is a syn or anti. Okay, now I will take the same example. Okay, this is our ketoxime, phenyl methyl ketoxime. Now here, methyl group and OH are at the same side, while phenyl group and OH, they are present at the opposite side, means it is anti-phenyl methyl ketoxime. Now this molecule on reaction with concentrated H2SO4, we know that it should be undergo Beckmann's reaction, means here phenyl group migrates on the nitrogen and we get corresponding N-substituted amide. Okay, this is N-substituted amide. Actually, this is N-phenylacetamide. This is CH3 C double bond O NH2. This is acetamide. But that acetamide having one phenyl group on the nitrogen. Therefore, it is N-phenylacetamide. This reaction is a Beckmann's transformation and it is a stereospecific rearrangement. Now, why it is stereospecific? Because in this reaction, the group which is anti with respect to OH, that group migrates from carbon to nitrogen. Here, carbon having two groups. One is a phenyl, second is the methyl. But carbon वरून nitrogen वर कोणत्या ग्रुपचं मायग्रेशन होतं? The group which is anti with respect to OH. OH ला अँटी पोझिशनला असणारा जो ग्रुप आहे त्याचं मायग्रेशन होतं फ्रॉम कार्बन टू नायट्रोजन अँड thus this is stereospecific reaction. Now in the particular example, here phenyl group is present at the anti position and therefore that phenyl group migrates from carbon to OH, carbon to nitrogen and we get the N-phenylacetamide. Now to determine the configuration of ketoxime, that ketoxime is subjected to Beckmann's transformation followed by alkaline hydrolysis. म्हणजे कोणत्याही किटॉक्साइमचं जर आपल्याला कॉन्फिगरेशन डिटरमाइन करायचं असेल तर आपण पहिल्यांदा काय करणार आहोत, दॅट मॉलिक्यूल इज सब्जेक्टेड टू Beckmann's ट्रान्सफॉर्मेशन. म्हणजे त्याचं पहिल्यांदा आपण Beckmann's ट्रान्सफॉर्मेशन करणार फर्स्ट स्टेप, फॉलोड बाय अल्कलाइन हायड्रोलिसिस आणि मग त्याचं आपल्याला अल्कलाइन हायड्रोलिसिस करायचं आहे. ऑन अल्कलाइन हायड्रोलिसिस वी गेट एन सबस्टिट्यूटेड अमाइड. ज्या अनसबस्टिट्यूटेड अमाइड आपल्याला मिळतोय त्याचं जर आपण अल्कलाइन हायड्रोलिसिस केलं, वी गेट मिक्सचर ऑफ कार्बोक्सिलिक ऍसिड अँड प्रायमरी अमाइन. and from the nature of that carboxylic acid and primary amine, we can determine the configuration of ketoxime. ओके, पुन्हा एकदा मी एक्सप्लेन करतो. आपल्याला कॉन्फिगरेशन डिटरमाइन करायचं आहे बाय युजिंग बिकमन्स ट्रान्सफॉर्मेशन. तर आपण दोन स्टेप कॅरी आउट करणार आहोत. यामध्ये पहिली स्टेप कोणती आहे? दॅट कंपाऊंड दॅट कीटोक्साइम इज अलाउड टू बिकमन्स ट्रान्सफॉर्मेशन. फर्स्ट स्टेप. सेकंड स्टेप कोणती आहे? corresponding product is allowed to alkaline hydrolysis. We get mixture of carboxylic acid and primary amine, and by using the nature of carboxylic acid and primary amine, we can conclude about we can determine the configuration of ketoxime. Let us see example. मी पुन्हा एकदा example explain करतो, मग थोडंसं लक्षात येईल. Okay, same example. Yes, this is our ketoxime. Name is a anti-phenyl methyl ketoxime because phenyl group and OH present at the anti position. In the first step is the Beckmann's transformation. Suppose it is created with concentrated H2SO4. In first step, what happens? That phenyl group migrates on the nitrogen and we get the corresponding N-phenyl acetamide. Okay, first step is Beckmann's transformation. Now this product, that intermediate, further on alkaline hydrolysis. This molecule undergo hydrolysis. Okay, this bond undergo breaking. OH group adds to one side. While hydrogen adds to another side. मग आपल्याला प्रॉडक्ट काय मिळेल? CH3COOH. This is the first product. CH3 C double bond OH acetic acid. Then second C6H5NH2. This is called aniline. And thus in this reaction we get the mixture of two products. One is the acetic acid and second is the aniline. Okay. Now this is the stereospecific reaction. In case of anti-phenyl methyl ketoxime, we get acetic acid and aniline as a final product. मग यावरून तुम्हाला काय कन्क्लुजन करता येतं? This indicates that phenyl group should be migrate. म्हणजे aniline मध्ये phenyl group आहे, aniline मध्ये C6H5 ग्रुप आहे, phenyl ग्रुप आहे. याचा अर्थ काय लागतो त्या ठिकाणी? That phenyl group should be migrate and it should be anti to the OH. कारण बेकमन्स ट्रान्सफॉर्मेशन मध्ये काय होतं? बेकमन्स ट्रान्सफॉर्मेशन मध्ये जनरली अँटी ग्रुप इज मायग्रेटेड. म्हणजे जो ग्रुप OH ला अँटी पोझिशनला आहे त्याचं मायग्रेशन होतं आणि तो जातो नायट्रोजन वरती आणि त्यापासून तयार होतो अमाइन, त्यापासून तयार होतो प्रायमरी अमाइन. Here in this primary amine there is a phenyl group आहे. This indicates that phenyl group should be migrated. म्हणजे phenyl groupचं मायग्रेशन झालेलं आहे. म्हणजेच phenyl group कोणत्या पोझिशनला असला पाहिजे? That phenyl group should be present at the anti position to the OH. Yes, thus from the nature of product we can determine configuration of ketoxime. Now let us see another isomer. यामधलं दुसरा आयसोमर आपण बघूया. Suppose this is the another isomer of ketoxime. Now here OH and methyl group, they are present at the anti position. मग असं असेल that compound is an anti-methyl phenyl ketoxime. Suppose this compound is allowed to react with concentrated sulfuric acid. We know that yes, it should be undergo Beckmann's transformation. Here there is a migration of methyl group takes place on the nitrogen. We get corresponding N-substituted amide. Okay, the product is N-methyl benzamide. Now this N-methyl benzamide further on alkaline hydrolysis. This is the second step. It on alkaline hydrolysis, same type of hydrolysis occurs. This bond undergo breaking. OH adds to carbonyl carbon, hydrogen adds to nitrogen, and we get the product C6H5 C double bond OH. This is benzoic acid. Then second compound is the CS3NH2, and this is nothing but the methyl amine. Thus in primary amine there is a methyl group. In the final product, primary amine having methyl group. This indicates that methyl group should be migrated and that methyl group should be present at the opposite side of OH. And thus, from the nature of product, we can determine the configuration of ketoxime. And this is a very, very important reaction, Beckmann's transformation or Beckmann's rearrangement reaction. And we are using this reaction just to determine the configuration of oxime, determine the configuration of ketoxime.